So in the business world, programmers will often work in teams or have to demonstrate their code to their supervisors who will often enough not have any programming knowledge whatsoever, which kind of sounds silly, but it's the nature of the beast. So the question is, how do we make our code understandable to everyone, even the untrained? Well, the simple answer is readability. What that means is our goal is to make our programs as easily readable at a glance as possible. This means it needs to be well structured and well explained. To do this, we're going to use a technique called professional practice. These are standardized systems of practice that are used throughout the industry, and yes, every company will vary this to some degree, but really the same basics apply just about everywhere. And we're going to be looking at three major things to handle this. We're going to be looking at program structure, we're going to be looking at white space, and most importantly, we're going to be looking at documentation. So what is program structure? So program structure is really what belongs where. So in every program we have a certain setup. We know our programs flow from top to bottom, but they're broken up into certain chunks, and we got to make sure that everything is where it belongs. Not only that, we got to make sure that things are broken up into what we call code blocks. A code block is a single series of commands or programming lines that work together to perform a single task. So for example, you might have a code block that represents your variable declarations for all of your input data. You might have a code block that represents the calculation of a certain series of functions. So for example, you might have a code block that decides whether two things are colliding, like two rectangles are intersecting or whatnot. So each code block can be anywhere from one to numerous lines of code. But the codes need to have a similar goal in mind. They shouldn't be completely distinct. What that also means is that just because that they're all doing the same thing doesn't mean they belong together. So for example, all of my variable declarations, just because they're variable declarations doesn't mean they belong in the same code block. What that means is that the similar ones belong together. So I might have my variables that are used for input. I might have my variables that are used for calculations. In essence, what is a code block really? Well, think of like an essay. We break our essay into chunks called paragraphs. These paragraphs allow us to separate pieces, separate ideas. And what it does is it allows us to break up the text and make it easier to read. Well, that's the same thing that we're doing here. We're breaking up our ideas to make the code easier to read. So, the next piece we're going to look at, and really is an extension on these code blocks, is white space. White space is that blank space that goes between pieces in order to make the code readable once again. So for example, in between each code block there should be a single space. So that's one piece. White space also dictates things like indentation. So when we have something that needs to be indented, it should be indented in the proper location by the proper amount. So we got to make sure that everything is located where it needs to be. The final piece we're going to look at is something called documentation. And there's a few places that we use documentation. We have something called a header. We have our inline, also called our code block documentation. Short form is docs. And then we have our variable documentation. And this is actually closely related to the code block docs. So what is a header? Well, a header is exactly what it sounds like. It's the head of something. It's the top piece of your program. Nothing should be above this in your entire program, not even the libraries. So the header should be the first thing at the top of every single file in your program that you code in. The header consists of 6 pieces of information. The author, who wrote the code. It should also include the file name. It should also include the project name. So what's the difference between these two? So in this case, the project name would be the same as your namespace. The file name is typically the same as your class. And then your creation date. So what date did you create this file on? And then your modified date. What is the last day that you actually changed anything inside of this file? This allows us to backtrack in case of errors if we run into any problems. That should be a D. And then finally, description. Give me a description of what the purpose of this file is. So if this is the only file in the project, this essentially is telling me what is the purpose of this project. Why is it being built? Now, how do we actually do documentation inside of our programs? Well, to do it, we have two strategies. If we're only going to add one line of, let me just erase this. If we're only going to have one line of documentation, we can use the // operator. So each one of these is called a comment because we're making a comment about the program. And so if we're only doing that one line, we put that // on, and then we write our text after the //. When C# sees this // that tells it to say, when compiling the code, ignore everything on the line that follows the //. So it's just going to pretend it's not even there. The other form of commenting our code is when we have multiple lines of documentation. So for example, in the header has 6 lines at least, because the description might be multiple lines, but the header has at least 6 lines. So since there's so many lines, rather than putting // at the beginning of each line, we could actually use a shortcut called /*, and then we end it in a */. Think of it almost like opening and closing brackets. So they're the inverse of one another. So this is an opening bracket at the top, /*. So the opposite of /* is */. This tells us that we're closing the multi-line comment. So we know how to make a single line comment. We know how to make multiple line comments. We know what a header is. What do inline and code block docs mean? Well, we discussed what a code block is. It's like a single paragraph or a single idea, a series of commands that perform a single idea. What I want is for every single code block in your program, I want a comment. Tell me what that block does. What is its purpose? So for example, if your code block is your variables that are going to be handling all the input data, then you should have some line of code that says something like data to hold user input. It's short, it's concise, I know exactly what it's doing. Sometimes you might need to be a little bit more specific. So for example, if you're doing one for all of the for a calculation, you might want to include the formula inside the comment, just so we know exactly what it is. The variable docs is very similar to code block docs because, as we just explained, variable docs are just another variables can be broken up into blocks just like any other series of code within your program. So I've discussed a lot of different elements here. So what we're going to do right now is we're going to go to a program and we're actually going to make the modifications. That's going to be our next module.